22, and our project is using machine learning to auto-suggest songs for Spotify playlists. So, according to the International Federation of Music, curated playlists have gradually replaced thematic broadcasts in the public's music consumption. Consumers often use playlists to encapsulate moods, categorize their music, and enhance music listening events. Each consumer has underlying music tastes and preferences, making playlist curation a highly complex and multidimensional task. So, why use machine learning? Many streaming services use machine learning to aid consumers in creating playlists because it will differentiate their company in the streaming market. And improving recommendation systems has been a heavily researched area as companies want to improve user engagement with their content. One of the most prevalent issues is making the first few recommendations when there is little information collected on a user. This is known as the cold start problem, and many researchers have attempted to address the issue in novel ways. The dataset we're going to be using was given by Spotify and consists of 1 million user-created playlists sampled from January 2010 to November 2017. Each playlist in the dataset has a playlist title, track list, and other metadata fields for the playlist. Each track in the playlist includes the song title, artist name, album name, and other relevant metadata. To the right is a sample data point given by Spotify. So the goal here is to create our own machine learning algorithm to auto-suggest songs for users to add to playlists. These playlists may be completely new with no features despite a user-defined name, or they could be well established with multiple tracks. We will then present 500 new suggested songs for users to add to their playlists, which aids consumers in creating new playlists or enhancing their old ones. Selecting an appropriate algorithm takes into consideration several factors, including the problem trying to be solved, speed, and the amount of data at hand. In a study by Urikli et al., it is shown that a combination of playlist titles or descriptions, latent semantic indexing, and singular value decomposition have outperformed current approaches. In our project, we want to attempt to incorporate methods researchers have used along with methods we have learned in class, such as the clustering algorithms. Some potential results and discussions. For each playlist that we evaluate, we will consider both exact track matches and artist matches as successful. 3 metrics that we're going to be keeping track of is normalized discount cumulative gain, which represents scoring how well tracks are ranked and is calculated by dividing the discounted cumulative gain of the retrieved tracks by the DCG, where the tracks are perfectly ranked. R precision, which is the number of estimated relevant tracks divided by the number of ground truth relevant tracks. And then testing how many refreshes it would take a user to find a ground truth relevant track based on retrieved recommendations. Spotify starts off recommending 10 tracks and shows 10 new ones for each refresh. For example, if the first relevant track is the 36th recommended, the score would be 3. And then here are our references. Thank you.